This is a web server. At first, it may look like a normal web server, and that's because on the surface it is, but internally it's about as low level as you can get. And this is because it's written in C, which is a language that was created in the 1970s and compiles directly to machine-readable binary code. Now, what would possess me to do such a thing? Well, a few months ago, I took a course on Udemy about computer networking, getting into all of the nitty-gritty details of routing, DNS, ARP, and a host of other things. It was here I got the idea to create this web server. The web server itself is very small, coming in at just over 200 lines of code. I'm going to explain how it works, but first, a little background. The internet works at 5 layers of abstraction, called the TCP/IP network stack. Each of these layers adds 1 layer of complexity. The first layer is called the physical layer. It's the actual hardware that transmits and receives the electrical signals for communication. Think optical cables, wireless cards, that kind of thing. The next layer is the data link layer. This layer is the first level that connects the hardware to the actual software. How does the computer handle hardware devices being connected to it? If you have heard of MAC addresses before, this is the layer associated with that. The next layer is the network layer. This is the layer which is responsible for routing information to computers which are not directly connected to each other. For example, you with the Google search server. The next layer is the transport layer, which is the first layer which involves the interpretation of sent or received information. You may have heard of TCP and UDP, which are protocols, which is a fancy word for a communication language, that lives on this layer. The final layer is the application layer, which is where web servers and pretty much everything else you directly interact with on the internet lives. So if we back up, you'll notice that there's this nice structure where you only need to interface with the networking layer that is directly above or below you. In our case, the web server lives on the application layer, so we only need to interface with the layer below it, which is the transport layer. There's 2 main transport protocols, TCP and UDP. UDP stands for User Datagram Protocol, and TCP stands for Transmission Control Protocol. The primary difference between these two is that UDP is a connectionless protocol, whereas TCP is connection-based. That creates the question, what is a connection? I'll demonstrate that with this little example. Here we have device 1 and 2. Device 1 sends a message to device 2, and that's it. Nothing else happens. Device 1 doesn't even verify that device 2 received the message. This is what we call a connectionless protocol. In the next example, here we can see that when device 2 receives a message, it responds back with a message acknowledged response. And in the case that the message isn't received by device 2, device 1 will retransmit the data. This is a connection-based protocol. Because UDP can result in lost data, it is usually an undesirable protocol for things such as websites that have text and images. We want them to establish a solid connection through the TCP protocol. Your computer actually provides functions for you to be able to directly send messages using the TCP protocol. Specifically, on a computer running a Unix or a Unix-derived operating system, such as Mac OS, these function calls are the primary ones involved with using the TCP protocol. And one more thing before we move on, I want to clarify some terminology. When we talk about computer networks, we use the term client and server a lot. The difference between these lies in their role. A server's job is to hand out data to computers that have requested it. They rarely initiate the network communication process. A client is the opposite of that. They usually initiate a communication with a server and request data from it. This can be in the form of text, video, images, and other data formats. In the example here, we can see that Google.com is acting as the server and your personal computer as a client. Here are some of the common system calls. A socket is a place where another machine can connect to. An individual socket exists on both the client and the server. This function spits out a number which can be used to reference the socket at a later time. A socket consists of an IP address and a port number. Bind takes the socket and assigns it both of these things. Listen tells a socket that it is available for incoming network traffic. Accept is a call that gets used for TCP traffic. Essentially, this is the call responsible for establishing a TCP connection. Send specifies a socket that you would like to send a message from. It takes the data in the buffer and sends it over the socket connection. Receive specifies a socket you would like to receive a message from. It reads the messages from the socket into a buffer. So now finally, the part you've all been waiting for, the code breakdown. You can see here I have the main function of the program. This is where all the actual execution happens. Up here at the top, we're making our system calls. I've conveniently wrapped these up in nice little functions to make them easy to interface with. If we dive a little deeper into the underlying functions, you can see exactly what we make our calls to: socket, bind, and listen. The next step is to create a loop which constantly checks for incoming connections. Because we're running on HTTP web server, we are using the TCP protocol. You can see we are using the accept system call to establish our connection. Once our connection is established, we can proceed with our logic that is specific to the HTTP protocol. We will come back to this function in a minute. The last step is to free all of the memory used in our web server. When the server shuts down, the memory is not automatically freed. This is because C is a language that practices manual memory management. Now you might be asking yourself, wait, you started talking about this HTTP stuff. What is that? I'm glad you asked. HTTP stands for Hypertext Transfer Protocol and is the protocol for handling nearly all of your standard web traffic. Whenever you visit a home page that serves you HTML, CSS, or JavaScript, you're using HTTP. HTTP is a text-based format. You can even see here when our server receives a request from the client what those HTTP requests look like, as well as the response which is sent back. This part here is what we call the HTTP header. And this part over here, you can see where the HTML is being sent back to the client. This is called the body. When this HTML is received by the client's browser, it gets processed by the rendering engine, which tells the browser how to display the HTML. Now remember when we said we were going to look at the handle HTTP request function a little closer? Here it is. This is the real meat of handling our HTTP requests and responses. First, we define our request buffer, which holds the incoming request traffic. Next, we actually read the request that was received. Earlier, we mentioned that you can use the receive system call for this, but I opted to use read instead. In the next steps, we're going to be pulling two values from our request, the HTTP verb and the URL route. The verb is what we use to determine which of these two paths we want to execute. Currently, I've implemented GET requests and POST requests. GET will fetch data from the server, whereas POST will send data to the server and tell it to add or update something, then send a response back indicating the success of the operation. You can see here I've broken the GET and POST requests into their own functions, so we'll take a look at those next. For our GET request, it looks a little overwhelming, but don't worry, the logic here is pretty straightforward. In this first conditional, we're checking if our URL route matches the route I have displayed on screen here. If it does, then we send all the messages that we've stored on the server back to the client in a text-based format called JSON. You can see we are using the send system call here. Now in the case that our URL route isn't asking for the messages, we try to find a file in our server folder structure that matches the route that was passed. We then try to read the contents of that file and ship it off to the client. Right now, we only have one file that can be served to the client called index.html, which contains a bunch of HTML code. Now, if either of these two previous conditions are not satisfied, then the route we are attempting to hit does not exist and we serve the client an error. So we're able to view the home page and get the stored messages with our GET request, but in order to add new messages to our board, we need to be able to send a POST request. POST requests usually have a body, unlike GET requests, because we need to tell the server what specifically we wanted updated or added. You can see here that when we receive a POST request on our messages route, that we are attempting to read the body of the request. Then we add a message to our server based off of the data that the client sent. Once we've added the message to the server, we send a response back indicating its success and message content that was originally sent. When that's all said and done, we can see that this short little C program is capable of serving a basic little website using only the standard C library and Unix system calls. If you want to take a closer look at the code, I have uploaded it to GitHub and dropped the link in the description. With that said, that's it for today. I hope you enjoyed the video, and I'll see you guys next time.